Hey guys, welcome to our Macroeconomics 2 workshop. So in this workshop, we'll be focusing on the mid-semester practice questions and how you should be approaching these types of programs in order to do your best. So question number 1, as you can see, this involves the Cobb-Douglas production function. However, they've put in a variation component called the human capital. Feel free to pause this video and look at these questions and try to work them out on your own and hit the resume button when you want to see how we work these out. Find the marginal product of capital, labor, and human capital. The most important thing is that to find the marginal product of any component, you need to take the first derivative in relationship to this product, as shown in this slide. So following on from the last question, we've put up the marginal product of labor, and now we're looking at the impact of an increase in human capital. As you can see represented by the fraction, the h to a third component is on the numerator, and therefore any increases will increase the marginal product of labor. What is the income share paid to labor and human capital combined if markets are perfectly competitive? So if you refer back to the production function, the components, aka the powers, represent the income share paid to the different components respectively. If you're looking to combine them, you simply need to add them together and find that the total share is 2/3. So this question is a little bit harder. Assume an unskilled worker earns the marginal product of labor, while a skilled worker will earn the marginal product of labor plus the marginal product of human capital. This is then asking you to find the ratio, and I've provided some multiple choice answers if you want to give it a go. Now for the solution. Firstly, we'll be looking at the unskilled proportion. So this is represented in the marginal product of labor, which we worked out previously. In terms of the skilled, we'll be adding together the marginal product of labor and the marginal product of human capital. So here's where it gets a little bit tricky. So first, we'll have the proportion of skilled to unskilled, which is what they're trying to ask for. However, we will then need to factor out a third, k to the power of a third. After doing this, we can remove it from our ratio, and we're stuck with the second line. Following this, we would then factorize out the 1 plus LH from the left-hand side, and this will give us the ratio of the skilled labor to the unskilled wage. Feel free to look over this a few times, because even I felt a bit confused when I was first looking at this question. So question number 2 involves the Solow-Swan Model as provided before, and this time you're asked to find the steady state consumption per capita and to show all you're working out. So the first part of this problem is to understand what is the steady state, and in this model it is important to remember that Sy equals gamma k. So once we know this, we can then begin to solve the problem. And in the second line, we've substituted in the y production function, and we've begun to start factorizing things out, finally coming to our result, which is the k to the power of 2/3. This will be used in the next slide and is an important first step. So using the new capital function that we just found on the last slide, we can then substitute it back into the original production function. After doing this, we then start to factorize things even more and expand them in order to understand what is our total output. So now that we have all of our information, time to find the consumption. So this is represented as consumption equals the amount of output minus the savings. Therefore, we can then start to plug in the numbers that we found previously, as shown in the highlighted. And then we also have to remember that the question is asking specifically for per capita. So this means that we need to divide both sides of our equation by L in order to get our final result. Question number 3. This question involves the Roma model, and we are aiming to find the GDP per capita on the balanced growth path. Please keep in mind that this is not your normal Roma model and that we have added in the influencing impact of capital. So the first step is to understand the amount of labor contributed to output. As you can see from the first line, this is simply a reorganization of the given material. Following this, we then factorize to end up with our end result. Now, since we know that capital follows the exact same functions, we don't have to do the process again, and we can simply understand that this is the capital function. So the first line is given to us, and in order to get to the second line, we will be doing the change in A in the period t plus 1 minus A to the t. This will give us our growth rate of A, and this is important because we'll then be substituting in the information that we found out in the previous slide. Now, this fourth line is something which we all have to keep in mind, not only for A, but for any other variable, in which it is that the value in period t equals the value in the previous period times by the growth rate function. Now, this finally ends up in our final result, which is depicted in the final line. Now that we have all of our information, we can begin substituting it back into our original production function. So in our second line, we have substituted in values that we've determined. And in our last line, we simply need to remember that the question is asking for per capita, and that we will have to derive both sides of the equation by L. So this brings us to the end of our mid-semester practice questions. I hope that you learned something from this video.